They're giving us here this indefinite integral to start with. So we're being asked to find the antiderivative of x squared over x to the third minus 6 dx. When we're dealing with antiderivatives, the good news is there's not a ton of rules for finding antiderivatives. It felt like with derivatives, you were finding product rules and chain rules and quotient rules and all that stuff mixed together into one big problem. When you're talking antiderivatives or indefinite integrals, really your only options boil down to the power rule, one of what I call a special case antiderivative, something you just have to be able to identify and have memorized. And if those two things aren't happening, really the only thing you've got left to play with is the U-substitution. And that's what you're looking at here. So what we have here is going to be a U-substitution problem. So U-substitution is a set aside work. It is the same set aside work every single time you do it. So you just got to get the steps down and it's the same steps every time. So step one of this process is you need to choose the U. When I look over at my equation, I have sort of my own little priority list that I've developed, and I look for these things. First, I look for a natural log if that's available. If that's not there, I look for what I would call the inside piece, as if you were doing a chain rule problem. So an equation plugged inside another equation. The third thing I would look for if those two things aren't there would be the bottom of a fraction. And generally what I'm looking for is the highest power of x, if I'm only dealing in powers of x. So going through this process right now, I would look over and I would say, okay, first I'd look for a natural log. Don't have that, so then I go to option 2. I'd say I'm looking for an inside piece. Nothing inside any parentheses, nothing plugged into a special case, so that's not there. Option 3 is the bottom of a fraction, and that's what I have here. So you would grab the full bottom of the fraction, and that is going to become your u in this situation. So u is equal to x to the third minus 6. Step 2 of our process is always the same. Step 2 is you now need to take the derivative of your u. So in this situation, that would be du dx. You always want to use this differential notation. It's critical to solving these problems. So du dx equals, power rule that. So bring the power down, subtract 1 from the power, and then the derivative of negative 6, a constant, goes away. So step 3 now, when we go to do this, and I do this different than probably most people, but it makes these problems so much easier. I have no idea why people don't teach this, but when we go to substitute in our u, we need this whole problem to be talking the language of u, and that includes changing that dx out. That dx needs to become a du. So to do that, what you're going to do is you'll take that derivative you just found and you're going to solve that equation to get dx by itself. Treat dx like any other variable. So first I'm going to multiply both sides by dx to get it out of the bottom. That leaves me with du equals 3x squared dx. And then the final move here is I just go ahead and divide by 3x squared, trying to get that dx by itself. And now what I'm looking at is du over 3x squared equals dx. So step 3 complete. I resolved that to get dx by itself. And now we're going to go and do our substitution process. So we're going to take that and substitute that in for dx. And we're going to take u and substitute it in for x cubed minus 6. I always tell people it's just work your way through this integral a chunk at a time. And it's either one of the things you're substituting in for or it gets left alone for the time being. So nothing happened to that x squared on top. All that stuff on the bottom there is now my u. And then dx is now going to be du over 3x squared. At this point in our process, any x's that were left in the problem should ideally cancel out with x's we just plugged in. And sure enough, I've got x squared on top and x squared on bottom, so I can cancel those two things out. And now I'm left with just a bunch of u's and some numbers. So rewriting this, this is really 1/3 sitting right here. Learning to pull these fractions to the front on these problems is going to be huge. So this is 1/3 times, and then this is now just a 1 over u right here. And this is what I tell people, this is your reward for all of your hard work. This is a brand new math problem. And so ideally what you've done is taken something you started with and could not take the antiderivative of, and ideally turned it into something that you do know how to take the antiderivative of. So at this point in the process, it should either be a power rule or one of your special cases. And what we're looking at here is one of our special case antiderivatives that we just have to have memorized. So this is the natural log. So if I have a number over x just to the first power, this is the only time this is true, then what I'm going to get out of there is whatever that number is times the natural log of the absolute value of x plus c. Never forget that absolute value of x. So coming back and looking at this 1/3, that's a constant. It just comes along for the ride. And then the antiderivative of 1 over u, that's really an a up on top of 1, so we don't really need to worry about it. And so then this would end up being the natural log of the absolute value of u plus c. And then your final move on any U-substitution problem really is to remind yourself you didn't really care about u, you cared about what u was. And so you're going to take and you're going to plug back in for that u. So RU was x to the third minus 6, so you're going to take that and plug that in, replace that u with x to the third minus 6. And so that's going to be your answer. And you'd look up and you would say, cool, got it, right here, done and done. Thanks for watching my video. If you liked it, please click that like button and subscribe. And also share it with your friends and anyone else you know who might be crying about an upcoming AP Calc test. You can find more videos from me, more sample AP Calc questions, and my complete AP Calc study guide over at my website, apcalcprep.com. Have a great one.